Okay, so just to summarize our last lab where we went through, downloaded, and compiled Asterisk and then installed all the binary modules, and we were able to get into the Asterisk CLI to see that Asterisk was actually working. Now that we have all that done, I do want to summarize and look at all the different commands we used in order to achieve that. And one great tool that's built into Linux is the history command. So if I type history, it is a simple command that's by default installed. I hit enter, and that's actually going to print out all the different commands I used prior to that point in time. Typically, by default, the history command is going to store around 500 commands. So at this time, I haven't completely filled that up because I'm only at 153 here. So I can scroll all the way up back to where it will be the first command that we ran, which is going to be the ifconfig command. So you can see the first command we ran all the way down through all the different commands we ran throughout the whole installation process. So that's a great useful tool for yourself to be able to capture what you did in the past, or if you don't remember a command that you may have used, you can just print that out. I've also gone ahead in the course notes or this lecture's notes is include a whole list of all the commands that we used, and keep in mind when you're using Linux it is all case sensitive. So if there's an upper versus a lower case in certain instances, that's going to be that may make the difference from a command working or not working. So that's an important differentiator between using your typical Windows or Mac operating system versus Linux. So be very careful about the case sensitivity. Alright, other than that, I didn't want to go into anything else. I'm going to do a quick summary presentation next, and then we'll jump into the next chapter. As I said, I just wanted to do a quick summary of the commands that we used. So going on to our first set of commands we ran to prepare the Linux environment, we used the ifconfig command to find out what the IP address was of the system. And the first time we ran it, it did not have an IP address. So we actually had to go in and edit the configuration file for ETH0, which is the network card that was part of the Linux VM. We enabled that ETH0 Ethernet card, restarted the network service, and after that we did the ifconfig and got our IP address. ifconfig is basically the exact same thing as ipconfig on a Windows system, except it's for a Linux system. After we did that, now we had internet connectivity. The system could actually go and download the updates for the operating system. To do that, we used the yum-y update command, and that's the Linux version of Windows Update, where it's going to go and update any security patches or anything that's installed on the system and get that to the current version. After that, we did a reboot using the shutdown-r now command, and the R simply stands for reboot, and we have to give the shutdown command a time frame of when we want to do that. So we use now to say that we want to reboot it right now. And then after the system came back up, we did the yum command again, and this time we were installing additional packages. Here I have the list of all the packages that we actually installed throughout the whole installation process. So when you go through this next time or down the road, you can actually just install all of these up front instead of installing them piece by piece. Next, we went in and downloaded Asterisk. What we did was go into the user source directory. That's the best place to really store your source code files. So keeping that on the system, if you ever need to go back and recompile or do anything, you do have those source files available. We downloaded it from the website with the wget command, just using the URL as the option there to just download directly from that website. And then we use the tar command with the zxfv options to extract that tar file. And then that created a directory of all the source code files. Once the source code files were extracted, we went into that directory. So we did the cd command to get into that certified Asterisk source code directory. In there, as long as all those prerequisite packages were installed previously, we can run that configure command. The configure command should give us a makefile, generate a makefile for us, and tell us that the system is ready to compile. At that point, we run the make command, which is actually going to go in and compile all of those modules and all the source code into executable binary files. After that's done, the make install command is going to place those compiled binary files into the correct system directories throughout the operating system. So it's actually going to create directories and put the correct files in all of those directories across the Linux operating system. And then the last command was make samples, and the make samples command is going to generate those example Asterisk config files that we haven't actually touched yet, but that's going to be coming in the next lab. And then we had to get the Asterisk service up and running so that after a reboot, the Asterisk server would be up and running. We wouldn't have to go and manually start it. So to do that, we had to copy out a file from one of the included source code files, and that's the executable Asterisk file that we put in etc/init.d, and it stored it in the file name of Asterisk. That file does need to be executable. By default, it was included in the package directory as an executable file, so we didn't have to do anything to that. When you're using some other versions of Asterisk, it is possible those won't come as an executable and would need to be converted or modified to be executable. We'll cover that a little bit later in the lessons. And we did need to edit that file by adding the correct sbin that Asterisk was stored in. We used the find command to actually locate where that was, but we found that it was in /user usr /sbin. And then the next line, we created an alias to a library for the 64-bit systems. If you're running on a 32-bit system, you shouldn't need to run this command. What you would see if you didn't do this command, the error you're going to get is that exit status 127 that we saw in the video. And then service asterisk start, once we have that all up and running, service asterisk start is actually going to execute that top file that we copied into the init.d directory, and that's going to initiate Asterisk running in the background. So to have Asterisk run in the background every time we reboot, we want to use the check config Asterisk on. That's going to set it up so that when the system boots up, it's going to look for the services that it should start by default, and Asterisk will be one of those now. So every time you do a reboot, Asterisk will be persistent in staying running regardless of what you do after that reboot. And then the last thing we did do was to just disable SE Linux. For simplicity, we're not going to use SE Linux throughout this class or course. We want to just ignore SE Linux. So using the SE status, we just want to make sure that it is disabled. And to disable it, it does require a reboot. And then the last command on here is the service asterisk status, just to show us what the current state of asterisk is. So you should be able to do a reboot on your system, log in, run service asterisk status, and asterisk should be running. If it isn't, you will want to run that check config command again. That's at the very top. All right, well, great work. We finished the first lab. You should have an operational asterisk server at this point. So now we hop into section 2, where we'll actually start working with the config files and adding SIP endpoints so we can actually do something with asterisks.